adjust my camera, did I? Uh-oh. Yeah, that should be good. Hey there, good evening. I'm still halfway preparing here, but it'll have to do. Uh-oh. I had some encoding lag. I was recording with different settings, and now... Uh-oh. I'm still getting encoding lag. Let me see if I can change my settings on the fly. What did I change that it's not working anymore? I know. I need to restart OBS real quick. Yeah, I'm using NVENC, but it's only on a GTX 1080, so it's a bit old, so the video engines aren't that great. And when I'm recording, I record in 10-bit, higher quality, etc. But now I have to record and stream at the same time. It's not doing that very well. I will be right back. Let's not end the broadcast, but stop streaming. I'll be right back. One moment. There. Let's see if that fixed it. I don't actually know. Time for 4090. Yeah. I wish. No, now's not a good time for ads. So, am I back? Let's see. Let's see if I have everything right now. So this looks good. And this looks good. I'm not seeing encoding lag. Music is a bit loud. Yes. Music should be somewhere over here. Unless this is pre-recorded, you are back. Nice. Cool. Yeah, so I still had the OBS color format space, whatever you call it, set to a 10-bit format and not a 8-bit NV12. I fixed that, and well, that was probably overloading my video card and having to do recording and streaming at the same time. So now we should be good in full 60 frames per second, and yeah. Yeah, I think so. Audio track 1, yeah, that's good. Okay. Yes, good. Hi, welcome. Good evening. Let's take a look at the drinks we have for tonight, and that way I can also check if this camera is working. It is. We have 2 drinks. The Fanta Exotic Taste, it's now called. Before it was just exotic, I don't know. And we have a new contender, Fanta Raspberry, that a friend of mine got me. And I also have a lot of special Cokes, but I've not drank Coke in a few weeks because I kind of want to detox from the Coke, I guess you could say. So we're drinking one of these, and I'm thinking I'm going to start with this one and then save this one for later. So they added taste, yes, exotic taste. They probably saw my streams and were like, "Why is this guy putting all kinds of words and stickers on our cans? We have to add more words." So they added more words. We need HDR. Yeah, I wish I could do HDR, but then I certainly need a new video card. I mean, this GTX 1080 is serving me pretty well so far. Yeah, this can is 330 milliliters, so this one. Does this work? Yeah, 330. And this one is 250. Where are we? Yep, 250. So, what are you guys all drinking tonight? And let's see, Jacco, wait. Still a bit coffee, sorry. Jacco Weiss says, countdown to the music starts. I've missed the live streams. I've missed doing the live streams, but sometimes I have to focus on videos and other stuff too. Surprisingly early, better get a drink, says James Derrick. Envy Enk, time for 4090, yeah. We need HDR. Hey there. Oh, airplane can. What? What's an airplane can? Is this an airplane can? This is what we buy in our supermarket. Yeah, I think if I make the chat narrower, the heart will just follow, or I cut off the text. I have to edit my CSS, I think. Not sure. Wim Kramer says, goedenavond. Goedenavond, Wim. Okay, I'm getting no rendering lags or encoding lags anymore. That's good. Nice. No. So I asked I asked what you guys were drinking tonight. 20 centiliter soda cans can be used to serve on airplanes. Oh, okay. Well, that's what they sell here in the supermarket. So, oh no, Philip. Oh no, almost missed the stream again. Chateau de Bordeaux 2021. Well, it's Friday. Oh, that's a fancy drink there to have there with us on the stream. Pepsi Max. That's okay, Chordo. Always water. You're an alien? You came here to drink our water? Now, of course, I'm streaming, so I guess I need to talk. I was just thinking about a lot of stuff. But yeah, beer is like 97% water. So technically, you got a point there, Philip. 1 hour from now, I will be drinking beer, says Johnny Bergdahl. Dr. Pepper Zero. Still haven't been able to get a hold of that one. After seeing your tutorial about flickering lights, I had success. The 33 ohm position already solved some problems with my X-Light show. I'm starting for the first time. Nice, Wim. That's good to hear. Well, that's why the option's there. I mean, right? So let's just get started, because I'm not that chatty as I normally am. So today we're going to take a look. Maybe I'm slightly too hot there. Today we're going to take a look at these guys. And these are, let me find the right way up. There. Where is this mouse here? Yeah. Is the camera a bit dark, or is it okay? Let's make it one tick lighter. There. No. Yes. Ah, okay. Well, now it's a bit bright. Oh, God. Okay. So, these are a board. What generation is that? What do you mean, what generation? These boards we developed a while back. It was actually a fun project I wanted to do during one of my vacations. What are you gonna do, right? So these are the dig2analog, and these are the final production versions. So that also means I have 10 of them here, and I tested 2 already, but we need to test more, because I want to see if these actually do what they're supposed to do. So what these do is they have a little chip on there, a WS2814F chip, and my God, I need 10. Please send them to me now. No, and that chip basically decodes the digital LED format we use with all our LEDs, and then this board translates that to 4 analog PWM outputs. So we've got RGBW. If you can see, yeah, this is the maximum zoom, but I can put it closer. Maybe. There, yes. So we've got the RGBW output over there, and well, that outputs RGBW to an analog or dumb LED strip. And well, that's basically the main function of this board. It does 2 kHz PWM, and there's some fancy stuff on there, like a buck converter, so you can have 12 or 24 volt in. It has a built-in fuse. It has actually special dual MOSFETs, so that you don't have to send an inverted signal. And well, it does everything for you. So basically, you hook it up like an LED strip, and then what you get out is a controlled analog or dumb LED strip. Why 4 and not 5? Well, there's really no RGB CCT support in WLED or ESP Home for that matter. And I don't know of a well-supported chip in WLED that will do RGB CCT. If you do, please let me know. But that's why we're using the WS2814, because that's well supported in WLED. 24 volt. I bought those fancy CRI 90 lights you recommend. Oh, from Oxmer. The Electro Dragons I have are no good. Oh, okay. Sorry to hear that. You want RGB CWW? What? Okay. Oxmer, yeah. Yeah, those make great light strips. Well, that's one of the use cases. If you have a digital controller, but you want to add some good white LED strip, you can't really do that with digital strip, but you can just add one of these boards and it'll act as a single pixel or LED, and then you can control it with a dig uno or dig quad or dig octa, and you can have high quality whites while still just using digital instead of analog controllers. Norwegian water. Ooh. Do you have a date when the Quinled A and Penta will be released pre-assembled? Yes. I don't have a date yet, but we have finally made some breakthroughs. So it's still on the top of the priority list to get that done. They keep burning up on me. Oh, well, that's a good design. Okay. Well, the pre-assembled boards that are coming will be able to do that, Neil, but these should be able to do that too. Stream just dropped to 144p. Oh my god. Yeah, they're cheap, but they're how will I say, simplistic in design, if I can say that. Send them, please. No, we first need to test them, Neil. See if they actually do what they should do. Now, let's hook up one, and then let's do a few tests with them, right? Because, well, that's what this stream is about. We're going to be testing them. So, as a testing setup, we are going to use a Quinled Dig Quad. Oh, sorry about the wiggles. Quinled Dig Quad, which is connected to a Meanwell UHP 500-24. So that's 500 watts available. That should be plenty of power. This is a 10 gauge wire, so that should also be, not cause any voltage drop. And then on the output, we have 16 gauge in a 3-wire format, because these use 33R resistors. There's no resistor switch on here. And when you're hooking up the board, I need to find a better solution for that. You can actually hook up the positive and negative on 3 spots. You have it incoming over here on the downside, over here on the top, please note the labels, and here on the side. So you can power inject these boards. Now that assumes that you have something else that does fusing on your power transportation lines, which of course the dig quad does. So that's no problem. But in situations where you want the analog LED strips to exit at the right, you can use it in this orientation, or if you want to exit it at the left, you can use it in this orientation. And that's actually a feature I believe CJ wanted me to add. There's this little switch here which allows you to switch where the data is coming in. So currently it's set to the bottom, so that's over here, or you can set it to the top and then data comes in here and goes out of here. So let's keep it at the bottom, and let's hook up the wires. And as I said, I already tested this one, so these terminals are open. Sadly, there was a miscommunication, and these screw terminals now have a minus screw in them, or a flat head screw instead of the Phillips screw I like. But as manufacturing issues go, I guess that's pretty minor. They're still high quality screw terminals. They're rising clamp screw terminals with a decent size, so you can get this is 16 gauge with a wire ferrule in there easily, no problem. Okay, so now we have a positive data and negative hooked up. Let's hook up a LED strip, and this is a cob LED strip, which is, well, as you can see here, RGBW and 24 volts. Okay, so let's hook that up. Still getting used to this autofocus. I'm not sure about it yet. So for some weird reason, black is positive on these. Oh, didn't put it in right. How well PLA burns? What? You shouldn't burn PLA. So, in theory, it is red, green. So red at the top. And then we have green, yes. And then we have blue. And then we have white. Okay, so again, just as a summary, we have positive data and negative coming in and into the bottom. So our switch over here is set to the bottom position. And then we have a positive, that's black on this strip, red, green, blue, and white, as it's also labeled over here. And, well, let's put the strip on screen. Let's put everything on screen, I guess. There. I believe this power supply, no, it's not connected, so I need to make sure I have the right power supply connected, because otherwise we're going to blow stuff up. Now, I already tested this week with this dig quad, so it should be pre-configured, but let's see. Power. Oh, well, it lights up orange. That's good. I'll show you that configuration real quick. Let me log into that dig quad. Let me put that over here. This one, I think. There. Okay, so this is the WLED that is on that dig quad. Let me go to LED preferences real quick. And what we've configured here is we have the brightness limiter turned off because we're now going to use that feature. Then we have it configured for SK6812 RGBW in the BRG format, so blue, red, green. And then we're swapping white and green. And we've said that we have 10 pixels. Of course, this board is only 1 pixel, but, you know, we want to be able to test things. And so if we now in WLED say we want red, it goes red. I can't really see what I'm doing like this. There. If we want blue, it goes blue. And if we want green, it goes green. And in theory, if we turn off the color and turn on white, it goes fully white. Now, some special tuning I've been doing with this version is, in theory, if we go to, this is 21%, or no, not 21%. WLED goes from 0 to 255 in regards to brightness, but this is 10. So 7 is off, I believe. Yeah, no, 8. So yeah, oh yeah, I was wondering if you could see that on camera, but you can see it on camera. This is very dim, right? This is barely lit, and I also tuned it so that if you max it out, it basically has no more PWM. So let's test that real quick. If we up the shutter speed, so we're now at 3200 shutter. And if we go to a lower value, we clearly see that we have PWM interference, right? Because these boards will do 2 kilohertz PWM only. Can't go higher, can't go lower. But I tuned it so that if you max it out, even at 3200 shutter speed, there is no PWM noise. So that means this LED strip is running flat out the max, basically. So we have a good low end, and we have a good top end, and that's basically what I tuned it for. And you know, that took a little while to get that right, but that works very nicely now. I mean, you see, this is 1/25 shutter. You see some PWM noise, but it's not too bad. Generally, Paul, if they're in groups of 6, you should be able to cut them per 6. But normally on the strip, well, you see the copper points between each section, so... Right, so, well, this is basically to show the basic functionality. I can hit it, I can set it to blend, and it'll do funky colors and stuff, right? But of course, the idea is that you can hook up multiple. Or rather, if you just want high quality white, well, you can do it like this, and then you can have a segment in a chain or on a separate data output or whatever. You can connect any analog strip you want, including high quality white ones. So for today, the first test I want to do is connect this bunch of wire, and I'm going to remove the WLED screen, this bunch of wire, which is 10 meters of 2-wire cable, in between this board and the next, and see if the data signal survives, right? Because, well, it should, but it's always good to test. So we're going to hook it up like this, lazy style, and we're going to make the red one the data signal and the black one the minus. And why am I sending both? That's because this board has 33R resistors on there, so using a 2-wire cable is better in that regard. And it's also better if you want data to travel further, as long as it's tuned for that, you know, for that type of cable. Okay. So we get our second board, and we input. We input the data and the negative on the bottom side. But of course, this board won't have power, right? So let me finagle this. Oh no. Oh no. Hold on. Okay. So, as I said, this board won't have power. So I'm going to take power from my dig quad here. And we're going to act like it's 10 meters away. Of course it isn't, but, you know. Nope, wrong screwdriver. Not in WLED. So my true analog boards will be able to run 14-bit resolution in ESP Home. It depends on the frequency you set, but these boards are 8-bit only and 8-bit only and 2 kHz PWM. But my true analog controllers that will come out at some point, they'll be able to do 12, 14, even 16-bit at different PWM rates and have very smooth transitions if you use ESP Home. That's also why all the background lighting you see here, they're on a very slow transition of 10 seconds from color to color, and they pick a random color each time. And, well, you probably don't even see them changing because instead of having 255 steps for each color, it has thousands, so the transitions are very smooth. Right, so now we need to inject power to this board because this board doesn't have power over here. So we're going to do that with the extra injection terminals. And I need to wind those down. Yeah, WLED internally works 8-bit. And there is talks about maybe changing that to 10 or 12-bit and using dithering and blah, blah, blah. But currently, WLED was purely 8-bit. So even if you hook up something that's capable of it, it won't use it. Let's get this out of the way. Okay. I don't know about this motor, but I know ESP Home does do it. Okay, so let's get a second LED strip. One of the things, if we have time today, I might want to cut a few of these up and make 1 meter pieces, but on the other end, that might just take too long and I just want to run some tests. So, right, so currently this is already on. I don't really want that. I seem to be missing my tool. What? Where's my tool? One moment, please. Okay. Do I have a different tool I can use? No, not that one. Maybe this one? I wanted to pull the fuse, but they're, you know, close together, so... Well, maybe I can get to this one. Yeah, okay, I was able to get to that one. But I do need to figure out where my tool went. Anyway, let's hook up the LED strip. So let's start with positive. It's always best to hook up electronics when they're not powered on. Yeah, it's mainly it's 3 resistors that are in parallel and in series that determine the bottom end, the top end, and well, how much power it can actually go through. And it's a combination you need to get right to well, get the most out of the chip you're using, basically. Because it's all pull ups and pull downs to do this. While keeping in mind that the timing still needs to be correct for a 2 kHz PWM signal. Okay. So we have a positive, white, blue, green, red. That's good. Let's put the fuse back. Ah, this is a different color white. Okay, that's fine. But that is immediately good news. If I go to the WLED instance, and I'm going to put it over here real quick. And let's turn off white and turn on green and orange. Yes, good, excellent. So now these 2 boards are connected together with this 10 meters of cable in between there. This is 18 gauge and it's 2-wire, but you know, that's fine. And well, that seems to be working. So now if we set it to blend, the effects are coming over. There's no flickering or anything like that. So by default, each board can handle 3 amps because there is a 3 amp PTC on here. And that can be any one channel or all of the channels combined. But I've made a special provision on the back where you can add another PTC if you want. So you can raise that limit to 6 amps. And there's also some extra provisions here where you can solder on diodes yourself if you want to for inductive loads and things like that. So by default it's 3 amps, and if you want to, you can raise that to 6 amps. But even if we set it to, let's set it to solid, red, full power. Okay, we're drawing 60 watts, but that's with 2 of these. And, well, 60 divided by 24 is 2.5 amps. So, single color, one of these is only 1.25 amps. So, that's well below 3 amps. We can go to blue, it's probably the same. Oh, it uses a bit less power. Green, it uses only 34 watts. We can go to a dual color. Ah, wow, okay. So that's using 98 watts. So that's 4 amps in total, but divided over these 2 boards. Let's go to RGB white. Oh, that's 103 watts, 123 watts. That is 5.125 amps. So even at RGB white, the 3 amps is still enough to address 5 meters of cob LED strip. So, although 3 amps sounds like, well, a little, you know, not much, in reality, it's actually pretty good. Let's put it back to blends. We can put it on rainbow. That always looks nice. There. Yeah, that's pretty cool. Voltage range is basically 12 to 24 volts. Okay, so that was actually the first test. And that was to see if it would do 10 meters of data wire, which, well, it did. So that's fine. Okay. Good. Well, that's good, right? I mean, I kind of expected it to do that, but you never know. Now, what happens if we remove the ground cable? Well, it still has a pretty good connected ground, so it's probably going to be fine. Yeah. Oh, maybe not. Nope. Oh, okay, maybe it is. I don't know. But if we disconnect this one, well, then the data signal's gone, so... Yeah, then it'll just keep its last state, and it just won't receive updates anymore. Right? Because it needs the data signal to get updates. So, if we connect this, it gets updates again. So now it's purple. Or red. And it'll stay that color, because, well, there's no data signal anymore. Okay, well, we don't need our 10 meters of cable anymore. Okay, let's unhook this one and see if we can indeed trigger the PTC. Okay, so let's put this one to the side. There. Let's unroll my LED strip here, because we're going to be using it max power. Yes, each board is a pixel on itself, so you can control those individually, and you can chain basically up to 600 or so. No, it's RGBW, so you can chain, let's say, up to 500 or so. And then you need to move to a new data channel, and then you can chain another 500. Okay, so we have this LED strip lying loose over here. Let's take the other LED strip. let's disconnect power. And hook it up in there. And hook it up to the same board. And then see if we can overload it with power, as we said. And then it's going to be the question, what pops first? The fuse on the dig quad, or the fuse on the dig2analog? Well, oh, sorry about that. Okay. Now we basically squish these into the terminals together. 5 times 500 is 2,500 meters. About the distance I walk between bars. Okay, so I'm just doubling up each terminal, and that should allow us enough power to trigger that PTC. Hey there, Ray. Come on. Of course, using these barrier style or these rising clamp style terminals makes it easier to use wires without ferrules. I'd still recommend using ferrules. Okay, last one. There. And let's get my my heat camera, if I can find it. Where did it go? What? Where's everything gone? I don't understand. It has to be here. Oh, I know where it is. Hold on. Hold on. Will there be a board option with the without the connector soldered? Riemann Snyder, by default, no. But if you want a larger order, we can always see what we can do. Because if we know in time before we produce the batch, then we can just produce a portion of the PCB, a portion of the PCBs without the connectors. But by default, we would populate them all. But since this is, you know, my production, I you know, if it's, I can't do that for 1 or 2 boards. But if you say like I want 100, we can certainly try to accommodate that in the next production, basically. Right. So we're going to be thermal imaging, but let's fix this to this one, and let's do that one, this one, there. Okay. So we can measure the temperature. This is less important now. Yes, okay. So we can, you know, does this work? Yeah, then it focuses on there. Good. So we can see how warm it gets. So let's power that on. Whoop. Okay, we're currently at 33 watts from the socket. So that's, you know, a little bit more than an amp. And oh, what's getting warm over there? Oh, okay. Well, I need to change this orientation, otherwise I'm confused. Hold on. There. Okay, so one of the MOSFETs, that's the, you know, this guy over here, is now 36 degrees. That's perfectly fine. Let's set it to full power. Not much changed. We're currently at 65 watts, so that is, I always say I don't do head math on stream. 2.7 amps. Okay, so we can see that over here, the PTC, which is rated for 3 amps, is starting to get hot. But that makes sense, because it should heat up when we're using this much power. MOSFET wise, it's 27, 28 degrees, 29. Yeah, that's all good. The buck converter, 27. Let's see on the bottom of the board, but I don't expect anything. Yeah, that's nothing. Okay. Let's go for a different dual color. Right, 96 watts. So 96 watts. Wow, that's bright. 96. This is 4 amps. That's a good value. And we can see that the PTC is indeed starting to rise. Trying to show you the number. It's too far away, huh? But it's only at 37 degrees. Okay. Let's go to white. So we're now at 120 watts, so that's 5 amps. I would have expected it to start closing somewhere around now. Okay, now it's 45C. Yeah, so the PTC is slowly rising, and if we keep this up for about a minute, it'll probably close. 46. Yeah, and if it's 46 and a half now, it'll continue doing that until it's too long over the limit, and then it'll close. Of course, this is meant for a short circuit situation where, you know, the fuse is really meant for. And then it's not going to do 5 amps, but it's going to draw 10 or 20 amps, and it'll basically instantly close. Yeah, it's 48 degrees now. Funnily enough, the rest of the board, the MOSFETs, etc., they don't care. Of course, we're doing RGB white, so let's add the white channel. We're now at 153 watts. Okay, PTC is at 59, 60... 61. Trying to show you. Okay, I'm going to try and zoom in. There. 67. 68. 69. 70. It'll start closing pretty soon. 153 watts still. Again, all the MOSFETs are now turned on full power, outputting to 2 strips. No problem, board stays cool, everything's fine, MOSFETs aren't even heating up. I mean, this MOSFET over here is 33 degrees, 34 degrees, 42, that's fine. Okay, we're at 80 degrees, still drawing 152 watts. But it's slowly decreasing. 152, 151.8, 151.5. Oh, now it's going faster. 150, 149. Oh, there he goes. So this is basically how a PTC works. The more you push through it, the hotter it will get. And at a certain point, it reaches its threshold. And then it just cuts off power, because this is now red while everything is still turned on, and it's only drawing 11.9 watts. Right? The cool thing is, though, this board is still online. I can still, as you can see, it went white now because I lowered the brightness, and if I up the brightness again, it still keeps functioning, because it allows enough power through to keep the controller online, basically, while the LEDs are severely limited in power that they can get. So if I now say, okay, remove the white channel and go to blue, there, it does that. Because that is below the power level, and you'll see that this PTC slowly starts to cool down again. In theory. Sometimes you need to remove power for a little bit for it to fully reset, because it's still only drawing 21 watts from the socket. So let's do that. Let's turn it off. There, you see it rapidly cooling. 70 degrees. It actually heated up the PCB there. 60 degrees. 50 degrees. Okay, so now if I turn power back on again, there, it's back to drawing full power, 47 watts from the socket. So that's basically how a PTC works. Let's turn that down a little bit. Yeah, so it doesn't close instantly at 3.5 amps or something like that. You can overdraw it a little bit, but it's like, as we saw at 5 amps, it'll only take half a minute or so, and then it'll close. If you do that with 10 or 15 amps, when there's a real short, it'll do that in a split second. So, yeah. That seems to be working fine. And another thing we tested together with that, although we'll do another test here. Yeah. That works well. Good. The solder melt point. Oh, 380 degrees. Because these are production boards, so they're all soldered with hassle-free or lead-free solder. So 380 degrees at least. Unlike my prototype boards, which use 138C solder. But these are production machine-produced boards, so total power output is pretty good, and the protection mechanisms seem to function pretty well. Let's let that strip cool down for a little bit. This fuse, so that's this guy over here, is only in place for the output. So for what's going out of here, and especially this positive output over here. It does not do anything for over here. But that's why you should use it with one of the dig controllers, because then the lines that are over here are fused over here, and this one is fused locally over here. So then if you have 10 or 20 of these boards and you're running multiple injection lines, those all get fused over here, and then if one LED strip does something wrong, that gets fused over here. Hope that makes sense. Now let me try and find something real quick. Okay, this is a Doji S98 Pro, and it's a fair phone, and it's a decent thermal camera, but not if you want to use it for this purpose. I know I use it for this purpose, but it's really meant for objects that are at least half a meter away, because this lens isn't tuned for close-up work. I just use it because it's easy to use on stream, but if you want to use it for electronic inspection work, I also have a FLIR, but it's harder to use on stream. I would recommend getting a different one than this one, because as I said, its minimum focusing distance really is half a meter. So that doesn't really work for electronics on a desk. Okay, so I have some Oxmer strip here, and we're going to try and overload a single channel, okay? This is CRI 95, 240 LEDs a meter, 24 volt, but with 38.4 watts per meter. So this is brighter than the sun. So let's get that off the reel first, real quick. Because if you turn this on while it's on the reel, well, it's going to melt itself and the reel. Okay, well that's fine, whatever. So let's hook that up to a single channel and see how well that does. Okay. Good. Power. And we shouldn't see anything, because it powers up on the dig quad, which is set to orange. So let's, okay. Let's turn on white. Oh man. Okay, so we're immediately at 67 watts. Well, we're at 50%. Okay. Let's go to 100%. So that is 136 watts. So that's 5.6 amps. Okay. Let's measure how warm that gets. You can see how bright that is. Oh wow, that's actually above the fuse rating too. Oops. But what I wanted to see is how warm this MOSFET would get. 52 points. Oh, okay. Later, Johnny. Yeah, that MOSFET is getting warm, but it's not too bothered. Now let's set it to not 100%, but slightly below it. 240. Okay, now that MOSFET is starting to heat up. Yes, R-Pro, those guidelines do not apply to these boards. Okay, MOSFET is at 77C. Let's see here, PTC is at 60. That's actually not too bad. Well, I still wouldn't recommend pushing 5 amp through one of the MOSFETs. I kind of thought this would overload it, though. Overload the PTC also. So let's hook up the other side to push even more power through. So R-Pro, those guidelines are indeed normally for addressable LED strip. But in this case, the connection between the dig quad and this board is using 16 gauge cable. So those resistance issues that you have on the LED strip, those don't apply over here. Okay, so I'm going to hook up the back side also and see if we can overload it then, because even though this is very good LED strip, when run full out like that with full power, it's still going to have some voltage drop. There. Okay, maybe I should turn power off there. Okay. Try and finagle this in there. Yeah, good enough. Okay, nice. That'll do. That's not going to short circuit, I think. Go. Okay, nothing happens again. Hold on. Oh wow. We're at 50% and we're at 82 watts. Okay, let's go full brightness. Oh my god. Okay, we're at... Oh, okay. Oh! I think I know what happened. I bet you the fuse on the dig quad popped. Yep, that one's a goner. Okay, so this fuse on the dig quad popped. Okay. Okay. Well, let's see. Do I have a fuse here? I do actually. Haha. Let's turn this down. There. And there. Now we have a 10 amp fuse. Ha ha ha. Okay, full power. 169 watts. Poor little MOSFET. Doesn't know what's going on anymore. Well, the PTC is going to give out earlier than the MOSFET is. That's kind of how I designed it, but, you know, yep, there we go. Yeah, PTC says no. Yeah. Well, that's just how it is. So let's turn it off real quick. PTC cools down. 60 degrees. Okay, let's turn it on again. And now we can control it again just fine. Oh, MOSFET's 87 degrees. 89, 90. Yeah, I'd say this is too much. But you know, okay. Well, that concludes those tests. Basically, in my opinion, these MOSFETs can easily handle what we're going to ask from them. We shouldn't exceed the 3 amp load, but even if you do, it does that just fine. It doesn't get too hot, nothing explodes, no problems there. The protection for 3 amps is more than enough for normal usage. If you really want more, you can add this extra fuse here, as you can see there, extra fuse, and then it can do up to 6 amps, but it doesn't mean a single MOSFET can suddenly do more. It's not what this board is designed for, basically. But if you spread it over over the multiple MOSFETs, that should be fine. But what this is really meant for is if you have 10 of these in series and you have a 1 meter or 2 meter strip connected to each of them, then you can address each of those individually, basically. Let me turn this off again and clean up a little bit. There. Okay, I snipped off this end again because that's going back into the spool. And I don't want it to short circuit because this is expensive LED strip. Not as expensive as you can get, but, you know, doesn't have to be that expensive because this stuff is already the bomb. Sorry, this takes a little bit. So did they test okay? I can DM you for my shipping address. Yes, they did. I want to test one more thing, and that's hooking up 5 or 6 in series, and just seeing if that goes okay. I expect so. Yeah, but we can talk on Discord, and starting next week, I think we can start delivering these to people who really want them until we have the shop page up. But that should be soon too. So. You have 10 Oxmer strips. Nice. Yeah, this stuff is amazing. I really like this stuff. Yeah, it has various use cases, but especially if you want to use high quality whites, but you only have a digital controller, which is running at 24 volts, for instance. Yeah, this makes for a great solution. So let me get some more RGB WLED strip. I should have some more. This is RGB. No. Well, no. Oh. Yeah, this has leads. Okay. So I'm just getting some random strip here. Okay. Let me see how I'm gonna do this. I guess first you guys get to unbox together with me. Might need to raffle them. Well, no, the first batch was 500. So we should have a decent amount. So not to worry there. Okay. Where's the one I already used? Over here. Okay. You want one of them in $4.99. So one of the things that is not set yet is the price. I'm waiting to hear back on final calculations. What I'm hoping for, but don't pin me down on this, is that they'll be $5.99 a piece. And if you order 10, I'll do a 10 pack for about $50. So then they're $4.99 basically a piece. But don't pin me down on that. Because I'll never mention price information here again. Right, so let's start connecting these. Other way around. Problem is, if I don't produce 500, let's say I produce 100, then I won't be able to meet my price targets. Because if I produce 100, I'd have to make them $8.99 or $9.99 a piece. And if I produce 500, I can make them $4.99 and $5.99. That's kind of the issue there. But I believe there's a market for this. Otherwise, you know, I wouldn't make these. I'm just going to hook up wires here. Oh, right. CJ, you wanted me to stagger them? How do you mean? So this one has the output on the right. And then you want to do an output on the left? Is that what you meant? That's fine, Philip. Okay, that can's done. So output always... Oh, okay. So, like that. Now, you can't really stack these. Because then, I mean, they have these spiky things on the bottom. And then these would connect into each other. That's not good. So you kind of want to put it over here then? Like so? Okay. Doesn't really matter. Long standoffs. Yeah, of course. These are all M3 threads. So you could use standoffs and then stack them. That's no problem at all. But I'll do it still the same way. Well, Riemann Snyder, sure, but if you're going to stack them, you're going to need standoffs anyway. And just make them high enough so the boards don't touch on each other, right? So then it's no problem. Okay, so I should have some of these pre-made cables, and we'll have to make some others. All right, these aren't open. Okay, next one. Thanks for the donation, Philip. That's always appreciated. Minus data plus. Well, if you watched more of the live streams, we tried some different connectors, but that really didn't work well. So in the end, just to be able to release it, I went with screw terminals again, because I know those work. I don't have more of these connection cables right now, so we'll have to make them. But we can do that pretty quickly. We don't have to make them very long either. Yeah, only need 2. That's fine. I need 4 differential signal boards so I can send the signal to my porch LEDs from the garage control panel. I'm crawling 15 meters under the house where the dig quad board temporarily lives. Oh wow, okay. Yeah, well, those are, well, not the highest on the priority list. They're pretty high up there. So I'm not sure when I'll be able to release those. It's probably going to be in stages. So I'm probably going to be releasing the single version soon. That was actually going to be the secret of the today. But I'll show it again later. And then the more advanced system will come later. But yeah. The electric screwdriver is still there, but I'm too lazy to change out the head. So that's exactly why I'm not using it. What? Now you deserve another secret. What? So this is actually 3-wire cable that's 16 gauge. I've only been able to find one place where I can order that. And it's actually from Oxmer on AliExpress. But it's pretty sturdy cable, that's for sure. No worry, again, when we're doing a batch, I have to make those big enough to be able to hit some price targets. As I said, if I make 100, those will have to be $8.99, and if I make 500, they can be, you know, $6.99 or whatever. Okay. This white one shouldn't be here. Good.
Think I need an exorcist right now. Oh, hear your voice, but you are not around. Oh, visions of your face are breaking down. Left me. Now I'm living with you. I still hear echoes of you. I still hear echoes that I can't mute. They're haunting my dreams like a playlist of memories.
Nope. For some reason this is too tight. There. Okay, that's one jumper done. Second jumper.
Trapped with all the words you used to say. Yeah. How much longer till these fragments fade? Left me headed for the coast. Now I'm living with your ghost. I still hear echoes of you. I still hear echoes
Tight fit for these.
that I can't mute. They're haunting
there. Okay. Ferrule's done, so now we have 2 extra little connection pigtails here. Okay. Good. So, minus data plus. Oh no, I didn't screw them open far enough. Next. Oh. Okay, so that's all the... Wait, still don't have enough. 1, 2, 3, 4. Oh my god. Oh! Wait. Oh, I still also have a pigtail. Why did I think I was done? Okay. Last board. Oh. I opened up the wrong side. Okay. Okay. Phew. So now we have 5 boards in series, right? So let's curl this up a little bit. That's board 1. Whatever. Board 2. Board 3. Board 4. Yeah, this won't be curled. Whatever. Board 5. Cool. Okay. Now we still have to connect all those LED strips. Sorry, this is a bit boring. I don't know. Let's start with some grease strip here, which is RGB CCT. Now, we only have 4 channels, not 5, but that's okay. Yes. So on this one, I believe black is still the positive. Well, this one should be open with it.
They talk about another kind of world. Another kind of world.
What are you afraid of?
And
I'm lost in old ways.
let's hook up warm white and cool white together.
I'm not afraid.
Well, here goes nothing.
Yeah, it would be interesting, CJ, to see what kind of idea they have to use the board for. That's always what I love the most. I make this hardware and design it, and of course I have some ideas in mind what its intended use is and what it would be good at. But then you guys buy them and do all kinds of stuff with them, part of which I imagined you would do, and then part is very original and like, huh, that's actually a very good idea. So that's always fun to see your stuff being used in ways you didn't maybe expect or intend, but still is nice nonetheless. Right? So it's very unwieldy cable. But that's what you get with 16 gauge, I guess. Right, next one. We'll use some of this.
I'm lost in old ways.
I'm not afraid.
Oh, this is actually RGB, so no white. Oh, that's fine too. Do you guys find it relaxing to see me screwing? Okay, that sounded very wrong. Do you find it relaxing to see me attaching LED strips to controllers? Wow. Okay, such unwieldy cable. Let's not repeat that. Okay, still need to open these. Not that kind of live stream. Exactly, CJ. Not that kind of live stream.
It all burned down. I swore it was for the last time.
Bring in the electric screwdriver. No, I'm dedicated now. It's actually making me warm because the garage was very cold because it's a bit stormy outside. Any second now YouTube is going to kill the stream.
We can't help it, it's just chemistry.
So I'm actually going to take off my jacket. That's better. Much better. There. Is smoke planned? Well, we're hooking up hundreds of wires, it feels like. So who knows? Took the jacket off to the wrong music. I was just thinking that. I was like, I'm not going to say anything. Oh, man. Okay. Third LED strip hooked up. Why is this like this? There. Okay. Fourth LED strip. Where is it? Let's use this one. Come on, come on, come on. Oh, no. Okay. Sure, whatever. There, good. I need to open these. Okay. Interesting wires here, but I think it'll work. Okay, last board and strip. Why is this here? Go away. This is the wrong side. We're getting there. The music is also getting more exciting. I'm amazed there's still about 80 people here watching me do this for half an hour already. It's kind of like watching a painter paint Bob Ross on PBS TV. Well, he's more relaxed. I'm frantically screwing in wires here. There. That, in theory, is the last wire. Oh my god. Okay, let's make sure they're not on top of each other. And other than that, I don't really care. Let's fix this. Like so. I don't know. The dig quad is buried here. We're running off of a single 10 amp fuse. That sounds good. That's fine. It won't explode. How about I just hit the power? I have no idea if this is going to work. Sit back and relax. Oh, whoa, it's all orange. Nice. Cool. Well, that's not a bad result. Let's see here. This is the first one. So this is connected to this board. This is the second one. This is the third one. It's connected to this strip. And then the fourth one is connected to this strip. Over here. And then this one is connected to this strip over here. I can't really see, can you? There. Thanks, Iman. That's nice to say. Let's see if I can, Oh, that didn't. Oh, wait, no. Okay, yeah. Okay, good. So now it's all red, all blue, all green. Let's take out the color, white. Yeah. That seems to be working fine. Can we do blends? Ooh. So pretty. Well, I guess that shows off very nicely how you can have all these analog LED strips, but hooked up digitally and doing something else, at the same time, right? That's the whole idea. Let's go to Paletti. Where is it? Paletti. A little bit slower. More power. Oh, that's too much power for the camera here. Hold on. Nope. Okay, other way around. There. How you change the desktop WLED now on your right? Oh yeah, I have 3 monitors. So I have a monitor over here, which has OBS. Then I have a monitor over here, which has the chat. And then I have a monitor over there, which now has WLED. Running late today. Hey there, Sean. Are the boards addressable? Yes. Each basically is a single LED or pixel. And it extracts the data signal and then makes it a PWM signal suitable for dumb analog LED strip. Right? More power. I guess you can use insane amounts of power like this. Let's try and blow that 10 amp fuse. Let me return this camera to normal. There. Okay, let's start at let's solid, white, with the white channel. Oh. Is it flickering? Maybe. I don't know. Okay, we're at 73 watts. 130 watts. Why is it flickering? That's interesting. Okay, let's go full power. There. 325 watts. That 10 amp fuse isn't gonna last long. I think. Interesting. Let's start up the multimeter and measure the voltage at the end. Nope, I don't want this one. Well, the thermal cam won't really do much because it's, you know, all spread out over these multiple boards. So that's not a problem. No, that's a thumbnail. Tombstone inscription. Why is it flickering? Yeah. Okay, let's see if I can connect the multimeter. Device is not connected. Why not? Device is not connected. Really? Did I... Oh, I might have broken the Ethernet connection that's in there. Or the cable, at least. Let's see. No, device is not connected. Ah. Oh, wait. Oh. There we go. Nice. I straightened the cable and it works again. So, last board in line is this guy over here. Let's see what voltage it's getting, because I think we're having... Oh, that's not good. I think we're having a massive voltage drop. So, currently it's getting 24 volts. Well, it's on very low levels. So, let's go here. So, now we're at 150 watts. Oh, it's 23.4 volts. Let's go full power. 22.6, that's not bad. I don't understand why this is flickering. Let me turn off. So now it's not flickering, okay. No, Tom, you cannot do that. It's actually better to run ground plus data on a 2-wire cable in 33R mode for the resistor switcher. But if you want to run 4 wires, you kind of have to run, or 4 data signals, you kind of have to run 4 wires, and at best, again, 2-wire with ground and data for each one. Or wait for the differential boards, because that's really what they're made for. Auto ISO. No, I don't have Auto ISO enabled. Interesting. I wonder if this strip is borked. So red. Oh, wait, let me turn this off. Sorry, I'm mesmerized by the flickering that you can't even see on the camera. Will the differential board support sending 4 signals over one 4 pair? Yeah, so one Ethernet UTP cable. Yes, it will support sending 4 signals. Not the solo not the solar version that's going to be released first, but the advanced version will support that. Yeah, I'm wondering about that. It's hard to quantify the flickering though. Let me see if I can. Can I measure that? Not really. Oh, now the flickering is gone. Okay. So I'm measuring one of the PWM channels while I dim it. Yeah, okay, that's too low. Well, interestingly enough, it's the last board in the chain that's doing that. So how about we add some power injection? That's going to be interesting to see if that fixes or changes anything. Let's see if I have a pre-made cable for that. Oh, I might. There, this will do. How many 5 meter strips can you run from a dig2analog? Between 1 and 5. That's not really a question you can answer like that. Oh wait, I'm not sure I can get these wires in there. We'll have to see. No, these are probably too thick. Yep, too thick. Okay. My headphone is all twisted. Okay. Do I have some good cable here somewhere? Maybe we can try and use this. So James, that is a lot more complicated question, because if we're talking 5 volt, you can run 1 and then you still need to do power injection and things like that. But if you're talking 24 volt, you can easily run 4, so about 20 meters or 64 feet, because you only need to do 2 power injections on those in total. So yeah, it really depends. But maybe check out my last video where I go into what each board is most suited for. You need a lux meter, yeah. Okay, let's connect some power injection here. So these boards have been designed with power injection in mind, that if you're running a lot of them, well, at some point you might need power injection, right? Sure, there's lots of them, Nicola. I'd say. Yeah. Okay, so now we have a wire going from here all the way like that over here into the power injection terminals. I don't know. Maybe that changes the flickering. Maybe not. Let's power it on again. Whoa. it's just a lot of light. Okay, let's go, I don't know, 100%. No flickering here. Oh. Oh. White? Okay, here's white. And then more white. We're doing 352 watts. Okay, that's not. No, this one is still flickering. Interesting. It's only this one. Which board is this connected to? Oh, no, it's actually this one. I believe it's only the red channel. So weird. Okay, well, blends. Wear sunglasses. Oh, what strip would you recommend is using WS2811 but ordered with the fact 5 volts is annoying? Yeah. Well, it really depends on what your project is and what it requires. So that's going to be really hard for me to say off the bat. Watch some of my LED guides. Yeah, so this is behaving fine. I don't know. Might be the strip. It's weird, because I think this is the strip we also used before. Interesting. Okay, we'll do one thing. We'll try swapping out this board and see if the problem remains or goes away. Now I'm going to switch the boards first. Pink smoke. No, we didn't have any smoke, let alone pink smoke. So I got another board here. Let's just, hook that up. There. Yeah, 24 volt, you can go a long way before needing injection. "72 watching, only 23 likes. clickety click. Okay, try to do too many cables at the same time. Sorry if you can't see it. The desk is kind of full. Oh wait, maybe we can zoom out even more. Ha ha ha. You got 32 likes now? Nice. That went up quickly. Come on, little wired. Sure, Paul. Catch you next time. Okay, that's the LED strips. Okay. Fancier colored smoke. Yeah, I'll see what kind of capacitor I need to blow up to get a different color smoke. Maybe we should blow up some some tantalums or something. Oh, this one's not right. Okay, hold on. There. Okay. Maybe it's just, I don't know, wiring, but we'll see. Okay, so I replaced this board. Oh wow, you can now actually see all this area. I never zoom out this much. Okay, let's go. Beam. Okay, there we go. Let's refresh WLED. Okay, let's do the standard stuff. Red, blue, green, RGB white. It's still flickering. How is that even possible? Yeah, it's still doing it. Okay, so replacing this board did not fix this issue, and I just want to disconnect it while it's running to make sure it's actually that one. Yeah, okay, now it's perfectly fine. And now it's flickering. Okay. Yeah, that was white. So last thing we'll do is I'll get a different LED strip. I should have some here somewhere. And see if it goes away then. No dark modes, yeah. Okay, so this one bad, probably. Don't know. Okay, hold on. we'll try some of this strip. This is, I don't know what this is. I'd have to look it up. Wow. Okay. Seemingly I cut this at some point. Okay. And now the wires are on this side. I don't know. I'm just gonna hook it up and see if that changes anything.
Very much alike. Remember all the happy times we had?
Yeah, this is RGB CCT, but I'm just connecting both white channels together. I really should have stripped these any further, but I didn't.
All right. I'll tell you the truth.
Now, I'm not sure all of them are making contact, but, well, you know, at this point, we'll see. Oh, we're getting orange. That's good. Let's go. Let's see. Full power. Adding white. Yeah. Red. A little bit less power. All fine. Okay. So then it was the strip. You guys were right. I didn't think it was a strip because it was the strip we used before. So it was like, maybe it's my boards. Oh, I knocked the wire loose. Good enough. There. But yeah, this isn't flickering whatsoever. Yeah, that's fine. Very nice. How dare you doubt Quinl's boards? Yeah, who am I? I mean, what? Cool. Blends. No, that's blink. That's not blends. Okay, there, better. Well, that of course doesn't do white, so, you know. Oh wow, okay. Chase. That's funny. What is this one? The first one? And this is the second one? Yeah. So this needs to be like this. So now it goes... Now it goes the right order. Oh, almost. There. Now it goes the right order. Faster. Whee! Yeah, that's pretty cool. So, let's say the the bounce, where is it? Bounce ball effect. Bouncing balls. I don't know about that one. Yeah, this one is a bit lower power, but you know. No, I like the chase one. And then this and that. Let's go random colors. Old timer LED strip, yeah, right? I don't know, let's go Paletti. Ah, so pretty. Oh, you can't see. There, now you can see colors. Cool. Well, I'd say that concludes this test, and that also seems to be working fine. Except for a malfunctioning LED strip somehow. But the board we replaced doesn't seem to have been the culprit, right? Pretty colors. Cool. Well, let's return this to normal. So, I always owe you guys a secret, and the secret is that we're not in production yet, but I've decided to go ahead and start final runs of, or final preparations of these, and these will be the Quinled diff series, and then the solo sender and the solo receiver. So these will be the first in the lineup, and I want to make these because these are small and cheap to make, and well, they're a small form factor. So this will run UTP cable for differential signaling, so you can go 200, 300, 400 meters, and then on the receiver side you have a power input for 5 to 48 volts. You have a fuse, you have a capacitor, level shifter, and 33R resistor, so you can hook up a power supply and your LEDs or your addressable LEDs, or you could even hook up a dig2analog and then run an analog strip there, but you know, so you can transport the data signal over very long distances. So we're in the final stages of taking these into production, so I hope to have these in maybe a month or so, hopefully, right? I know that's a little bit too late for a Christmas rush and things like that, but that's just how it worked out. So that's kind of the secret of today. The other type of boards are also coming, but those will be next year. Cool. Well, I'm happy how this turned out, and that even the issue we had seems to have been the strip, not so much the board, right? And all these other strips are working fine, so I'd say the boards are fine. You can see the disco on my face. Let me turn up the brightness. There. Oh, now it's just mush. Oh well. How much power does this draw? 100 watts. Nice. Let's color myself with white. Oh. Ugh. That's 320 watts of white. Well, I guess you can see how many watts it is, right? My God. Okay. Pink. You want pink? Okay, let's go pink. A little bit more like that. Here we go. Pink wash. Should we do breathing? Where's the breathing effect? There we go. Oh, we could do one last thing. I always think of new things. We connected that power injection at the end, right? So the last board now receives power from a different line. So let's, I don't know, measure the power over here and see what the voltage does. Let's go back here. You can see it going up and down a little bit, but that's really minimal. Let's add the white channel and then go white. So now we're alternating between 350 watts and, well, almost nothing. It goes down to 23.5. That's not too bad, I'd say. Nice. Okay, anyway. So power injection also seems to work, right? That's kind of what we're looking at. Wow, that's a lot of light. Okay, hold on. Let's remove this and do like that. Yes, nice. Okay. Whatever. Tema asks, Quinled not available from AllNet Europe stock, but only from AllNet China. Yes, currently it's AllNet China only, but we are working, as I mentioned at the beginning of the year already, on making stock more available in Europe. Part of that is certifications and other papers we're trying to get so that we can easily sell locally and adhere to all the laws and things like that. So that is a work in progress, and I'm hoping we can proceed or move forward with that soon. So, yeah. Okay, well, that's understandable, Steve. I mean, the shipping costs and tax, that's real money, so I can understand that. Do you have a thermal camera to recommend? It's a bit tough. I'd go for a Chinese variant. So one of those, let's see what this app is called again. InfiniRay ones. So this is also the InfiniRay app. Those make decent cameras. As I said, this one is fine. This one's good on the S98 Pro. I like it. It's just that it has a 0.5 meter focusing distance. FLIR, I don't know. FLIR is okay. I have a FLIR, but it's not better than the others, and you can get more value from your money from other brands, basically. So, yeah, not sure what to recommend. Yeah, price-wise, if we have to import it, stock it, sort it, ship it again, pay import fees, someone has to do that. So price-wise, it's not going to be cheaper per se, but it will be available local, so probably faster, right? And it's also not going to be the whole lineup, at least not immediately. Maybe at the end of next year, I don't know. But yeah, it's going to be a subset first, and then we'll continue from there. Keeps on blinking here. Let's see, what can we do? Color loop. Oh, okay. Yeah, no. Well, let's go full power. Yes! Well, if you wanted a disco, this would do it. Do we have a coupon for Singles Day? No, but I might release a video or maybe a short on the 11th of the 11th sale, which is approaching. But if you want to have the discount codes and stuff like that, make sure you're on the Discord. I always post them there. But I'll try and do a dedicated quick video about them too. Halloween was previous weekend with these lights. Yeah. Cool. So, hadn't had a live stream in a little while. Next week there won't be a live stream. Maybe the week after that. I'm not sure yet. But it was fun to hang out with you guys again. Thanks for watching. I think these dig2analog boards, although a bit niche on what you'll use them for, I think they could be a great little solution, or great little board in certain situations where you're like, I really like addressable RGB, but I also need some primary lighting. Well, get one of these. And then you can just connect an analog LED strip to a second data channel on your dig quad and use that for analog CRI 95 high power task lighting or primary lighting, and you can still use the addressable RGB on the first channel, right? So I think it'll be a great little board for that. Do we get a video about the different antennas you did order? I threw those in a drawer. Maybe at some point in the future, that style. But yeah, under cabinet lighting, sure, yeah. A high humidity basement. Poor. I'd have to look into data sheets for that too, Nicola. In theory, most of the time, when equipment is on, it's not so much affected by high humidity. It's when you turn it off and then on again that it might be humid, that it might be an issue. But while it's on, it's generally warm, so no water or droplets or things like that will form on it. But yeah. Could you run a matrix on them? Well, if you wanted a 100 meter by 100 meter matrix, maybe. Wow. I don't know. Well, my voice is giving out, guys, so thanks for watching, and catch you guys next time. Bye-bye.